Once again, good afternoon to all of you. On behalf of Director, National Center for Advanced Studies, Senior Professor Premakumar Silva, sir, and presently Acting Director, UGC Vice Chairman, sir, and our Senior Research Fellow, Professor Nirmal Ranjit Devasi, sir, is there. So, let me introduce our resource person today. So, Mr. Tamalu. Mr. Tamalu is a data engineer working in HCV Mobile Solutions, and he works in artificial intelligence and data science related projects and mainly focus on natural language processing and business data processing. So he also he claims Sinhala language is tenseless, and his other interests are philosophy of science and epistemology. So frequently we are conducting like guest lectures at NCAS. So Mr. Tamalu, over to you. Please continue.
Okay, thank you, Dr. Sampath. And let's start. I like to make this session. You can hear me, no?
Yes, yes.
Yeah. I want to make this session be more like interactive, so I'd appreciate when I ask simple questions. If you, I open the video, then you can see me. Yeah. I like to make this session bit interactive, so when I ask question, I'd appreciate if you put your answers in the chat. I'm not going to ask any technical questions, so therefore I'm only asking about your experiences and your feelings, kind of things. Let's start from a question. What are the tools that you have used, or what are the tools that you know to generate charts, tables, or any other type of data visualization? It can be like softwares, platforms, libraries, modules, or physical device, anything. Just put in chat. Any more replies? Excel, SPSS, Stata, R, GIS, W, Matplotlib. There are a lot more things like if we get like SPSS, Excel, W, Power BI, then there's Naimi, then there are some other stuff like if you go into Python, there are like Seaborn, Plotly. If you go to JavaScript, there are a lot more charting libraries nowadays, like there are G2, eCharts, Google Charts, High Charts, Viz Charts, Vega. There's another project called D3JS. It's something more advanced than the normal charting library. D3JS is there. Like there are lots of charting libraries, modules, then tools. There are there. And another question I like to ask: what are the chart types that you know? You have ever created, or you have ever heard or learned? What are the chart types? Do you know, like bar charts, line charts, something? Can you put that also in chat? Different types of charts that you are familiar with. No messages? Okay. I think you know, like bar charts. Bar, pie, histograms. Another like line charts, area charts. These radar charts. There are some other charts as well. A lot of box plots. Then there are other things like Sankey's, proportion graphs, dumbbell charts, lollipop charts, donut charts. There are all sort of charts out there. We know, like here, we know some charts, and we know some platforms, and There are a lot more charts, a lot more platforms, a lot more softwares, but when we talk about visualization, there are more things than just chart types and software to learn. It's a very broad subject. There's a rich theoretical background and there's a practical application. It's more evident. There's a lot of practical applications, and we have to know about all of that. So I'm going in this lecture, I'm going to touch this theoretical side as well as this practical side. So let us start from this practical side. Now I'm gonna share my screen, and okay, can you see the screen?
Yes.
Hello. Yeah, you can see the screen. Yeah. Yeah. I have seen a lot of reports, newspapers, journal articles, reports, and I have participated in a lot of presentations. And what I noticed the world is filled with bad charts, ineffective charts. How we can get rid of that? How we can make more effective charts? How we can make good charts? What is to be done? To know how to do the right things, first thing, we should know how the wrong looks like. So I'll give you some examples. Please don't do these things. These are examples about bad charts, ineffective charts. I take this one from an report, Indian report, and you can see, you can comment like what are the bad things you are seeing in this chart in the chat, and I'll give my comment. This is looks very unprofessional, and this is ugly, and too much colors, too much space is taken, hard to read. Try to read this. It's hard to read this data. On top of that, the gist of a pie chart is we show values, we show sizes in angles, and we are going to compare those angles. Can we do that here? It's very hard. One thing, they have sliced it away, so it is hard to compare two things here. The other thing is, this is a 3D pie chart. You are supposed to compare angles, but they have distorted the angles. So 3D pie chart is against the gist of the pie chart. You are supposed to compare angles, but the angles are distorted. So this is very bad chart. Then this is I taken from a research paper. You can see this is a 3D pie chart. Same mistake is there. Angles are distorted, and there's 3D bar charts, and you can see like 3D is something coming from illusion. Our plane is, this screen is, your papers are, all those things are 2D. When you try to make 3D thing out of 2D surface, you are going to make an illusion. Now, in chart data visualization, all you are going to do is map complex data set into 2D plane, but instead you are mapping it into a 3D space, and then you try to make an illusion that looks like 3D space. It will not work. It is ineffective. We will discuss it later in thoroughly. What you can do, think about this one. This one is ugly, too much clutter, it's untidy, and it's very hard to read. Like you can see, like first language is Tamil and English is also there, and it's very hard, like you can see a line, then you have to go to legend, and then you have to come again to the another line and see the legend, and these colors are also not much different, or not enough to give a clear idea. So what's wrong about this chart? These are all those things are from Sri Lankan reports. You can see, try to read this chart, try to compare two things, try to read values, try to get sense of this data. You will feel like those bars are dancing in front of your eyes. Those bars are vibrating. Why? These textures are these stripes, like these dots, these kind of textures. It is hard for eyes to watch this thing. When computers were not around, like there were no option. We had to go to textures and have those charts. But when we have computers, it is just pathetic that people using these kind of textures. These textures made it very hard to get the information. So never use these kind of textures. Use colors and other properties. Never use these textures in the charts. Now, what's wrong with this? This looks like some multicolor, some fantasy kind of thing, but doesn't look much professional. And you have seen, I enlarged one of them. There you can see these grid lines are cutting some numbers, and sometimes it can be hard to read. There's a the biggest problem of this chart is something in the y-axis, the vertical axis. Could you figure it out? We are going to discuss it later, but there's a huge error here. What do you think about this one? This is from Department of Census and Statistics. This is in the FB page, and can you read this report? What do you think about these colors? It's these backgrounds made this chart very difficult to read, and it looks somewhat ugly, these line charts. And this texture of the horizontal bar chart is also somewhat something feel ugly. So this is also example for a bad chart. What do you think about this? These things might draw your eyes to the block, the post, but the important thing, like the main thing about these visualizations, what you can get from these images is that those images are made by graphic designers, not proper visualization experts. Look at that. It is hard to read. Like you can see in the left hand side is some kind of a ROS chart, and in this ROS chart, if you're going to compare those angles, it's hard because these radius are getting different, and when the radius are different, like the same angle might feel in a different way. And you can see in the this area, I think you can see my cursor, 5.9, 0.3%, 3%. Those area, like all the labels are coming together closer, and it's a bit crowded there. And here you can see in this bar chart, they want to communicate that they have changed the base year that they calculate GDP level from 2010 to 2015. When they do that, the GDP has positively increased. They want to communicate that message, but they're distracting that because this bar chart doesn't show intervals very much, the gaps very much. The other main problem is that here you can see the two colors, 2010 and 2015. The 2015 is in this color. The same color they are used for here for this old series, but they are using in the but they are using that color for the 2010 series in the chart. This is inconsistent, and rather than paying much attention and looking at a long time, only we can find what they're going to communicate. Otherwise, it's initial stage, it's confusing. A chart should be something like when you look at it at a glance, you should get the gist of it. What do you think about the left hand side post, FB post? It's also from DCS, Department of Census and Statistics. It's ugly, too much color, it's hard to read, and looks very childish kind of design. No? Sorry for the creators, but it looks that too. And in the right hand side, the colors are pleasing, but if you try to these textures are also like it'll making like it'll like it can give you a headache if you try to look at them a long time. And you can see here those percentages, they are marking it in a line. They say Vivasayam, and it's very hard to get the idea just looking at the graphs. Here is a recent one, and this air quality index one. You can see this table, this red, blue, those colors doesn't make any sense without looking at the table down there. But you cannot just read that once. You have to go back and forth again and again and again to get to decode those information. So it is hard. It's hard to read this chart, and it's not clear as like it's very hard to read those texts. Also, not much contrast there. Yeah. Now we have seen what we should not do. What are the bad charts look like? Then now we're going in. Now we look charts created by experts, so we can identify what's the difference. This is by Stephen Few, some early member in database community, and you can see here the target is given as this small horizontal line, and this bar is there for like actual comparing to that budget, actual expense. Now it gives clear view, and it's very clear, and it's very easy to read this chart. And yeah, this is by Stephanie Evergreen, and you can see here for every dollar earned by white men, women earned 8 by POC means black, indigenous, and people of color. It's a common term in USA. So you can see like for white men, this is the earning, and here this is the total. All women are like when we consider all women, this 0.3. Then when we go to unprivileged and like minorities kind of thing, like those women earns the wage gap is larger. It's clear. It's engaging, and it tells the story in a clear way, and we do not have to go back and forth to understand it. In a very short time we can get the clear idea. Yeah, this is called Nussbaum and Affleck. She works in Google and about the community. In her book, there's this graphic, and you can see the story is very clear. Like 2 employees quit in May. Before, like all the received tickets were processed. Now there is a gap. Now there is a considerable gap. So the business owner should immediately hire 2 employees. Otherwise, the business there's a huge gap between received and processed tickets. It's very clear. You can see like there's no much clutter. It's very clear. Now this Ama Nyamensa, she create like a growing share of adults access the internet on their tablet, and you can see like the key message is very vividly displayed. You can easily read this chart. Yeah. This doesn't represent like all the people in the data visualization industry and all the styles, but just some of the interesting things I seen in last several weeks, and just the things I remembered when I created this slide. So I think this will show you how good this will give you a feeling how good visualizations look like. And we go to the last example. That is specifically taken to make contrast with that air pollution index report. Here, Colin Ware is an expert in this ocean mapping and color theory. And you can see this is comparing to the normal time in the Pacific Ocean. The Pacific Oceans temperature in the 100 meters depth, comparing to in an El Nino season comparing to the normal temperature. And you can see like more redder means like more warmer than normal temperature in the El Nino season, and more blue means like more colder. And you can see that this is USA and this is Australia and this is between the Pacific Ocean, and you feel the texture and you feel how this redness, warmness, coldness, and this culture related to warmness and coldness also, that you can see like zero difference means white. There's like almost same difference. There's no difference in the El Nino season rather than comparing to normal temperature. Okay, now yeah, I have to ask you a small question. I open this I have opened this video. So is it hard for you to like see the screen because of the bandwidth problem or something, or is it fine? Like is everything clear? Like you can see properly, no? And hear my voice properly?
Yeah, yes, everything is okay.
Okay. Okay.
I think so.
Yeah. Then I'll open the video as well. Keep it there. Yeah. Okay. Now I'm going to give you some tips. I'm going to give you some tips how to make professional looking, good looking charts, and how to avoid bad charts. Never use 3D charts. 3D charts, like those things came into this one like when Excel getting popularized, then people wanted to show that they know fancy things and they know advanced Excel features, and they like everyone try to use a lot of 3D charts. But the problem is 3D chart is just it doesn't work that I'll describe it more later. So we'll get on the next tip. Never use pie charts. Yeah, this is something like Sri Lankans might not familiar with the statement, but in the database community in USA and other prominent other countries where this field is prominent, like this is a very popular fact. Pie charts doesn't work. Pie charts don't work. Never use pie chart. That's a rule of thumb. There are very special cases, very rare cases. Sometimes pie charts might work, but in general, the how people normally use pie charts are really bad. So it's better to avoid pie charts. You can read it from like some other books in data visualization industry, like this Evergreen's book. There are some other books as well, like when to use pie charts, but there are debate around those things as well. Usually many people agree that many professional data visualization people agree that pie charts are bad, at least in most of the occasions that people have tend to use pie charts. Don't use dark backgrounds. We the color, the sense, the color, the feeling of colors is it becomes different with background. For a white background, the colors sense like we sense color in a different way than a dark background. So to create visualization, to create designs in white background is something lot studied. Like it's very much like it's studied. Yeah, there are a lot of resources and a lot of rules and a lot of knowledge about that. If you go to dark backgrounds, you have to be an expert about dark backgrounds. Otherwise, you will mess up things. So I do not say like dark back like we like absolutely you shouldn't use dark backgrounds, but the thing is it's very hard to use dark backgrounds in a proper way. So better to avoid dark background. The best background is white. It's easy and there are a lot of things around it, and Usually all those like experts also created their charts in white backgrounds. We can create charts in dark backgrounds, but that requires a lot of expert knowledge. Never use images for backgrounds. You may have seen some FB posts that are circulating that shows the same color in different backgrounds. They feel like two colors. It's the same color. If you try to track the color, it's the same color, but because the background is different, it feels differently. So if you use an image, in an image, like color changes, at one part the color can be lighter, in the other part the color can be darker. So colors are also become different. If you use an image as a background, we can't guarantee what message will the chart convey. Everything get messed up. So never use images for background, never use dark backgrounds, never use 3D charts, never use pie charts. There are exceptions, but you need expert knowledge to handle that. Best you should avoid them. Okay, why pie charts are bad? Now you look at this chart. This chart shows how we feel several sensations. You can see length, it's linear, it's a line. When the intensity grows, the sensation also grows in the same proportionally. Now look at this part. When the intensity grows, when the intensity increases, sensation increases slower. Like if you double the power of audio signal, the volume sensation is not getting doubled. It's something like more like every electronic engineer knows. They have to use proper resistors, otherwise everything will be messed up. Area is also like that. Area, volume, brightness, loudness, smell. Like when it get increased, we feel lesser increase. So here you can see in these things, these things you can see this shock and there are several other sensations: heaviness, taste, duration. You can see in these things, sensation increases faster than the intensity. If we increase the shock by 1, we feel a lot more shock. We feel heaviness by 1, we feel it lot heavier. Taste is also like that. Duration is also like that. It's important. If we add one time unit, we feel like there are more increase of time, more delay. So that's why like people do not like waiting. Okay, now what works best and what works worst? Here you can see position along a common scale. This thing works very good. So charts made out of that concept will work. It will give a clear. They will give a clear message. And position along non-aligned scale, they are also good. Length is also good. So angle is little bit worse than that. Area, volume, those things very hard to feel the actual values. Like twice the area, we cannot feel it directly. Like when we see something twice the area, we do not feel it like twice the area. So so color also like that. You will think like you can see color. Yeah, you can see color, you can identify color, but can you identify like twice brightness, twice red, these kind of information? Like you cannot measure color. You can see color, you can distinguish color, but you cannot measure color, you cannot compare colors. So colors are very bad. Colors are good to show categorical information, but to represent a measure, they are very bad. It's hard, but sometimes we have to use color. But this is the case. Like, we have to think about what is the best way we can represent data, and if we can represent using very good, if we can represent data in a good way, we should not represent that in a bad way. Now angles law, that's the key to pie chart, and you can see, like, it is in the 4th place. That's not very good. Like, we are not much good at comparing angles, and almost everything we put in pie charts can be shown in bar charts. So pie chart is less effective. Okay, you can see these 3D charts. Why 3D charts are bad? Here you can see this 0. This the axis level is 0. Here this 0 is it is the bars, like, it is below the bars. You can see it is below the bars. Why it happened? Because this is an illusion. Like, 3D view is an illusion. We are supposed to think that this 0 is mapped to this level. It's an illusion. Then where would be the 5 there? Is this 5, or is this 10, or is this something greater than 10, or is this something lesser than 5? It's very hard to tell. Like, we cannot make, like, there are a lot of different ways to create this illusion, and we cannot just get clear idea when something is represented in 3D. And not only 3D pie charts, all pie charts are bad. Why? This is a pie chart variant that is called donut chart, and this is like sliced away, sizes are away. Here you can see, and the one problem, too much space. For a small number of information, there is too much space, and hard to you can see very hard to compare angles, and because we are using a lot of colors, for some colors small things looks like larger. For some colors, small thing like large things looks like smaller. If those colors go into wrong areas, like we will get a wrong idea about our data set. And here you can see, when we analyze a data set, it is very important to know about small things, like small segments. Like large things, everyone knows about large things. Everyone knows about large things. There's no magic in it. There's no something to wonder. Like it's like general knowledge. Most important information they are in the, like, smaller areas. So here you can see this is 19, this is 76. It's very hard to see which is what. Here also, like, you can see, like, these parts, like even the labels are very ugly. They have to put some lines, and you can see the problem here. So pie charts are bad. You can use a bar chart to represent the same information. Like you can show, like, the counts of single Tamil Muslim burger and other in a bar chart, and it will work better than this pie chart. Okay. Now we discussed about this practical side a bit. I cannot cover all. Yeah, I cannot cover all about practical things. I will come into some other practical things as well in the later of the lecture. So let's look into this theoretical side. First of all, I like to go into history. How data visualization started. You may have a horoscope in your home. If you have a horoscope in your home, like, it's a data visualization. Where the planets are there. Maps are data visualization, and there are a lot more ways to visualize data, and it's like these maps and other stuff, they were there for a long time. But the problem is, if we think about statistical data visualization, statistics, when people start using like data visualization to represent statistics, there's a debate about it. Usually people say like this is the first statistical data visualization. It shows it is in 17th century. It was created from Toledo to Rome. Different Toledo is a city and Rome is a city. Toledo to Rome, there is a distance, and different people have different authors have given different values for that distance. In this data visualization, all those like Toledo is here, Rome is here, and different distance estimations are given. You can see like this here is the name of the author, name of the person who give that distance estimation, and you can see like this. I do not know how to create this. I think this is Ptolemy. I do not know how to create these Latin names, but you can see like the variety of the lengths that they have given as the length between Toledo and Rome. This is statistical data visualization. You can see like this made the idea clear. This summarize this summarize complex data. Were there any statistical data visualization before that? That's a question. There are a lot of debate around it about other cultures, non-European cultures, and some history, and even Evergreen once wrote about something about this and indigenous American cultures had some data visualizations, but yeah, there's a debate. But traditionally, this is attributed as the first statistical data visualization, but there's debate. Okay, after that, the clear like the data visualizations that we are familiarized with, these bar charts, line charts, then bar charts, line charts, these area charts, pie charts, those things are created by a person named William Playfair. William Playfair is not John Playfair, the famous mathematician, but William Playfair has an engineer and economist, and he had like 20 or more other jobs, and even a secret agent kind of. Yeah, he created those charts, and it is in 18th century. So those charts we know, bar charts, pie charts, they are comparatively recent. Like 18th century is not a very long time back. Yeah. Now after him, there were other improvements like Florence Nightingale, the nurse. She made some nice visualizations, and there is like John Snow. John Snow is not John Snow, not John Snow. John Snow is a doctor who found that cholera is spread through water, and he had a map showing that his data. So there are a lot of improvements, a lot of chart types were created meantime, but there was a huge problem. Until computers came into the picture, it was very difficult to draw charts. You know, like, because you have created charts in school. It's very hard to draw a chart by hand. So until computers came, there was not much improvement in public domain. After computers came, you can see this is 2001 Space Odyssey in here also. This is a nice movie showing like how future technology will looks like, and it correctly predicts the philosophical changes in the technology. You can see here we can see a chart. So we can see like even in 1960, there was the idea about like showing charts in computers, and there were a lot of research also at that time. So yeah, but there was a huge problem. You think about a bar chart. Bar charts, there are a lot of there are huge variety of bar charts. There are stacked bar chart, like the bars are in stack on top of one another. Dodge bar charts, like bars are there are groups of bars in the bar charts, and bars can be thinner, bars can be fatter, bars can be horizontal, and axis labels, scales can be different, and bar shapes can be different, and colors can be different. There are lot of subtle variations in a bar chart. When you try to make a bar chart in a computer, you have to address all of that. When you create if you are going to create a chart generating software, chart generating library, you have to support all those bar charts. So you can imagine, like there are a lot of code there. When you try to implement a bar chart in computer, then there's a lot of codes underneath. The problem is when this code grows, there there are lots of chart types and lots of subtle variations. So the code will grow exponentially, and this will take computer memory, and the other hand, the chart libraries will be less flexible. They cannot handle a lot of variation, they cannot handle a lot of different chart types, because it's costful. Lots of codes has to be written to generate this thing. That was the nature about computer graphics before Leland Wilkinson. Leland Wilkinson, he is an interesting person. You have been like, this is a like humanities and social science related forum. So you can see here his like educational qualifications, like BA Harvard, BA is then Bachelor of Sacred Theology, PhD is in psychology. He's a psychologist, and his first job is as a professor of psychology. And while he was a psychology professor, he made a huge invention. We can come up to that. Yeah. You can before that, I like to go, because as a motivation I like to go into some details about him, because he came from a humanities and social science background, but he worked in technology. So some of these software. Systat, yeah, I said the problem with this computer graphics. At that time, there was a huge code base. While he was working as a psychologist, Leland Wilkinson created a package called Systat. It was very small in size, very small in computer memory, but it supported huge variety of different charts. It was magic at that time. We'll go into it deeper, but yeah, he created Systat. Then he sold this Systat system in 1995 into SPSS. You know SPSS, and then he was worked in like core team member in SPSS, and he created data visualizations there. And when the Tableau was created, he was vice president of Tableau. You know, that's a business data analytics software that creates good charts, like chart generation platform. And then he moved to H2O AI and AI firm company, and he passed away. He passed away last December, means 2021 December 12th. Until he was passed, he was in H2O AI, and he also like supported some community projects, chart related projects. I know, like I was working closely with I used some Chinese I used that product for my work. So that G2 was the project name, and Leland Wilkinson helped those guys as well to create those charts. So he's a huge name, but he came from a humanities background. He make the charting industry, this visualization industry, upside down. How he did that? How he created a small library that can create variety of charts. That's the question. He came up with an idea called grammar of graphics. Yeah, you know, I think most of you have heard Noam Chomsky. Noam Chomsky is a linguist. He's the father of modern linguistics. So Noam Chomsky has an idea like deep structure and surface structure of language. Usually in grammar, before Leland Wilkinson, we discuss about different patterns to say in languages, different sentence styles, different sentence structures, different word generating patterns, and so on. But after Chomsky came up with a new idea. Chomsky said there is same idea can be can be uttered in different ways. So yeah, same idea can be uttered in different ways. Chomsky theory says there is a deep structure and a surface structure in language. Deep structure is bound with ideas. Surface structure is bound with different language, sentence patterns and word patterns, so on. He said like language is something like we get evolutionary, and the same meaning, the same deep structure can be converted into different surface structures, different sentence styles, different patterns, so on. So he upside down the way we look at the linguistics. He went to the idea first and the deep structure first, and from the deep structure he gave like there are transformations to get surface structures. Wilkinson applied that linguistic theory into his chart generation process. Before Wilkinson, everyone tried to generate a pie chart, surface structure. There are pie charts, bar charts, line charts, different patterns, different styles, different patterns, and bar chart variations are also there. Like different styles, different patterns, different charts. Those are surface structure. Wilkinson identified if we are going to make something versatile, we have to apply Chomsky's theory, surface structure and deep structure. So we should not go into create codes to generate surface structure. We should identify the deep structure, and from that deep structure, we can generate these surface structures. We only want to develop to represent these deep structures in a computer language and these transformations in a computer language. If you if you write codes to generate those deep structures and transformations, you can generate any type of chart, any variety of chart, any surface structure that you want. Yeah, in short, like he didn't went to in the path like how to make a pie chart. Instead, he asked, these are the data, how in how different ways these data can be represented, and he represented the data in a deep structure, and from the deep structure you can see source, we get data, source, data, and there are deep structure to surface structure transformations, and after all the transformation there are 7 pipeline steps, you get the graphic. And he identified that only in the last stage these visual things come into the picture. up to here, it is all mathematical, completely mathematical. Only in the last stage that visual things come into the graph. We can discuss it in several weeks. This thing, it's very complex and very deep. So I stop discussing about grammar of graphics now. So it's an important area if you are going to study about this data visualization, and if you're going to do research and do some, if you want to know like how humanity is applied into technology, you should do research into this area. And now you know how generating different like large variety of charts in computers were possible because of this grammar of graphics. After grammar of graphics was invented, every charting library tried to use it. So so now like all the modern charting libraries you are seeing they are using grammar of graphics. And you know something like if you have used R, ggplot2, like they bring this into forward, and you said you like there is grammar of graphics. It's a simplified version of it. So yeah, here Wilkinson identified that there are several elements in a chart: data, transformation, elements, scale, guide, and coordinate. You can see like data, it's you can understand what's data, and there are transformation. We will go to this chart and try to understand. Like this is a chart that's showing birth rates and death rates of countries. Then here x-axis is birth rates and y-axis is death rates, and here you can see that every country will come into the as a point, and here you can see like this density. So more countries are there means that that part is more dense. Lower countries are there, that means less dense. So there's a like density contours are there, and here there's a zero population growth. The birth rate, if the birth rate is death rate, that means population growth is zero. In this area, birth rate is high, that means population is growing. That this area, population is decreasing. Yeah, you can see there's a data, there's a transformation. That's how we get these contours. Then element means these parts, lines, and other things. And yeah, battery is going low. We'll see. I'll yeah. Still power cut is going on some minutes. I'll let it. Yeah, we'll wait a bit. I stopped the video so I can yeah. The power cut maybe happen, and then like power cut happened. So now like at 4 it should be power should be come again. If there was like there would be little delay in between. Yeah, yeah. Here data, transformation, elements, contours are elements, and here scale is there. Scale is you can see like 10, 20, 30, 40, 50, 60. That's scale. And you can see this data, this guide is there. Guide means some helping parts in that zero population line. It's a helping part. And this guide, then coordinate, this is a rectangular coordinate system. These parts are there. So you can see yeah, you can see these are the components of a graph, components of a chart. So you can see there is still you can hear me, no? Can you hear me still?
Yes, yes, we can hear you.
Okay. Yeah, then I'll continue. Meanwhile, I'll get power. Yeah. Okay. Now, so far, we didn't talk about we only talk about how to generate charts, how to generate all charts. That was Wilkinson's idea. How to generate good charts, bad charts, all the possible charts. He wanted to generate as much as the variety that can generate, but not all those charts are good. Some charts are effective, some charts are ineffective, some charts are good, some charts are bad. Now, we want some theories to make effective visualizations. It is same in the language also. There is grammar. With grammar, we can write anything. So there is some theories about communication, and in this communication theory, we know how to communicate effectively, how to communicate ineffectively, what are the qualities of a good communicator, so on. Likewise, the critically batteries critically low. Okay, theories to make theories to we need some theories to make effective visualizations, that to make good charts. Okay, now you have seen this chart before. Now this is a chart about this is chart. So we discussed about it. So in school, we learn something like that, components of a chart. Components of a chart means the components that can be there in a chart, But our school system is bound with those exams. So there is an school exam mentality. So those components that can be there in the chart has been transformed into something else. Now schools teach those components as I regain the power, so we can continue. Okay. Schools teach okay, I'll come to here. Okay, with the school exam mentality, schools teach those components like something should be in a graph. Here, the components are the things that can be in a graph. Now it is converted to something should be in a graph. So they will give marks to each and every component of the chart. So they will not even stop by that. They will even reduce marks, saying there is no grid lines, there is more empty space. That is how our school system works. I think we all have experience about that. So they think these are the components of the chart, and you should have all those components in the charts, and for each component we are giving a mark, and if you want more marks, you have to add more components. So our school students will put each and every components into the chart and fill it with all the components. So they will get more and more marks. But that's really bad, because that's the most ineffective viewpoint. And this same thing happens in language. They are asking about essays, and they when the essay is longer and longer, they are very happy and they give more and more marks. But in real world, what we need is to convey messages in a short form. We need short essays that's saying a lot of information, a lot of interesting facts. No, but the school system works in the other way. That's unfortunate. But here now, I think we all are past the school time, so we can discuss about this effective data visualization. Okay, when we are going to talk about effective data visualization, there's a key person, Edward Tufte. You can see he's political science and this political science, statistics, computer science. You can see he's also from a humanities background, and his interest is political economy. That means the new political economy paradigm, like politics and economics, this interdisciplinary study people, and behavioral sciences. You can see all those people are like interdisciplinary researchers. You can see his book is The Visual Display of Quantitative Information. and he had some position in like Obama's government also, as I remember. But he in 80s, as I remember 1983, where he published this book, and he came up with an idea named data to ink ratio. He said we should maximize data to ink ratio. That means from we should minimize the components that do not represent data. We should have less ink, more data. If we are using some ink that doesn't represent data, we should best remove that. That is his key theory, key rule of thumb. You can see data to ink ratio. Now here we are again going into some practical examples, how to make this effective visualization. What's wrong here? Here it's a computer screen. There's no ink, yeah, but theoretically it is ink. Theoretically it is ink that we are seeing in black. I think this is as ink. And what do you think about data to ink ratio and how we can improve this? This has large borders, more ink without doing any functional, more ink without functional benefit. So we can remove those grid lines. So we can come up to something like that. And I changed the fonts also a bit, but we removed grid lines, but some grid lines we needed. I only kept necessary grid lines. And you can see, like, final result, we get some interesting chart. Compared to this is very easy to read. And if you think about this APA, social scientists use APA style guide. APA style guide is also like says to use tables like this. In 1990s, Leland Wilkinson is the one who was the main author of APA style guide as well. At that time, in the tables, they have given a proper instruction about the table design. So APA also has these things I'm discussing here. But chart design was not until the computers were get popularized and those softwares came, good softwares came, it was hard to design a chart. Therefore, there were less information about how to create good charts in APA guideline and in other journals. So still, if you look at main journals, you can there are a lot of bad charts. But journals are evolving, and slowly they will implement those effective visualization theories into their style guides, and then in future you all have to use these theories. So yeah, this is a good table, but some people might say this Western Central, there are only 9 provinces, so it is easy to read. But if there are a lot more rows, it might be hard to read. So in that case, we can do something like that using very less amount of ink. We can create these stripes, and this is a standard practice you may have seen. You can create a chart like this. You can create a table like this. So the next thing is bold, and this bolding text is also something making text difficult to read. It is good as a way to emphasize things, but it makes the text difficult to read. So bold is something you should really use. And center alignment is also same thing. We have in schools, we put titles and all the stuff in center alignments and think that's working pretty good. But center, most of the cases, left alignment, it's cultural. If we are going, if we are in a left to right writing culture, left alignment, right to right, left writing, writing culture, then it's right alignment. This left and right left alignment works better than this center alignment. Usually you can test it. There are a lot of center alignment titles are there. You can check after changing the alignment. Center alignment really works specifically for larger text passages. Okay, Now we will go to more important practical stuff. There's something called cut the clutter. That's the key thing. We should make the charts clean, make the charts looking more professional. So it's based on this data to ink ratio. There are two. There is the first. That's the first step of creating good visualization. So we are going to remove all the things that waste ink. So this yellow background, it waste ink. So I remove that. So then this, I can remove these borders, grid lines, they just wasting. Then this mark is also, it is also wasting. So I can remove this one. So I can, there's axis labels and axis is also somewhat wasting ink. You can put numbers here, less ink. You see how it improves, like this is better. Now this is better. If you can remove the axis, better to remove the axis, so it's better. And there are some more improvements that we can do, and we can there's no order here, like bread hoppers, kottu rice string hoppers, these things are like there's no particular order. We can just sort it out. Then now it's clear, and we can have ultimately we can have a chart like this. This is very clear, looks more professional. And even if we want to make this data ink ratio even lesser and make like space, utilize the space, you can create some these horizontal charts. There's another important benefit of horizontal bar charts, like when the names are very big, like there are sometimes there are large names come into here. If you put into a horizontal, like normal bar chart, when the name is higher, you cannot put it here. Then you might rotate it, you might put it in like vertical, it's hard to read. Rather than that, it's you can put it in a horizontal bar chart, so the names you can like easily like you can keep even long names, and the names can be read easily. And even you can put the numbers into here if you think it's needed. Then it's like a table combined with some bar to show the like visualization. Okay, now think about this. Like this is one way, like string hoppers, kottu rice bread hoppers, there's a salt. And think like it's like a meal pack. Now we know like string hoppers pack selling most, kottu rice bread and hoppers are selling less. And there are some cool stuff, like we can even reduce data to ink ratio by using something like lollipop plot. You can see it's a horizontal lollipop plot, and data to ink ratio is even lesser, and it's clear, and you can see. And even we can there's some another element like focusing things, like we can focus on like that hopper sells less, and we can create something like that. We will cover focusing in a later part. So you can see cut the clutter is important. The key step is that you have to remove all the ink that doesn't add data. That's the first step. You have to be radical in this. You look at it, cut everything out. You can remove it. You can remove. Then more you cut away, it looks more professional and more easy to read and more engaging. Okay, now we are going into another theoretical section after that practical section. So this is Gestalt psychology. Gestalt psychology, some may have heard. Every designer use it, not just the chart designer. Every graphic designers design like these mechanical designers, even I think architectures also use that. Like this is key to design philosophy. You can see here Max Wertheimer came with this Gestalt psychology. He criticized the dominant German structuralism, and Then Wolfgang Kahler, he came from a physics background into social science, psychology background, and there's Kafka. And those people, like they were against like the German structuralism at that time, and they criticized the structuralist viewpoint of like looking a system as its parts. You can read Kafka's this text. You can read it slowly. What's the important message he says? Some people says like system is its part, and some people is, go beyond that and say system is more than its part. Like Kafka says, like it is more correct to say whole is something else than some of its parts. That's their philosophy. Whole part relationship is something very different. Like whole is completely different from parts. We should study whole in a new viewpoint. That's their psychological tradition, philosophical psychological tradition, and that's applied in design theory. Every designer know Gestalt principle. They came up something with called pregnance. This is something about how mind group things, how our mind group things, and how we focus things. It's a psychological stance. So it is used in design theory. So we'll go into this Gestalt principles. You may have heard if you are a graphic designer or any other designer. First thing, before like discussing something, I have to remark a very important stuff, important thing. Negative space is good. Negative space is good. People in our school system, people say like you do not keep blank spaces, fill everything. It should be get filled. But in Gestalt psychology and in design theory, they look at negative space as a positive thing. So they say negative space is good. Actually, negative space is important. Negative space give space for readers. Then only they can understand the important parts in a design, important things in a design. So negative space is something important, and there are also negative space designs as well, if you have seen some logos and stuff. Okay, we'll go to this Gestalt principles. First thing is proximity. You can see proximity is nearness. When you see this, you can see like first thing, like there are six squares and 3 squares different, and there are, you see in the second like right hand side, you see there is 3 rows. There is 3 rows. Like here, there's a in the left hand side is a broad column and a short narrow column. So all 2 images consist of 6 squares, but we have a different sense about that. Yeah, that is proximity. So proximity is a way to way to group things. So yeah, similarity. You know, this black dots, we feel it as a one group, and this gray dots, we dark gray and light gray dots. Like dark gray dots, we feel them as one group, and light gray dots, we feel them as another group. So there is this 2 groups. You can see our mind group things based on similarity, and there's the principle of closure. Our mind see this as a circle, complete closed circle. So even it is just some segments. So there's the principle of closure. Our mind sees this closed circle. Enclosure means when we enclose something with when we enclose something, we see it as a separate group. Continuity. There are 3 line segments here. Here 1 line segment, another line segment, and there's another line segment. So there are 3 line segments. You can see, but when we look at this line, we see it as a continuous line. We see like this line is going behind this rectangle, and it is connected. These 2 parts are connected. because our mind feels continuity feels continuity, and it takes like it feels continuous paths and take things together as a group. So there is something again, symmetry and order. Even if you are not familiar with math, you have a basic feeling that these two parts are related to something and these two parts are related to something because of this symmetry. Symmetry, you can think like this is a one group, this is another group, and this is another one group. You feel that because of like our mind sense symmetry. So now this connection, when some things are connected, we feel those things as groups. And figure and ground, when we see something like we see several things as foreground and we see some things as background. When you see at this image also, you will find several components as foreground and several components are behind that as the background. This figure ground relationship also there. Then the last one, common fate. Common fate means like you can see like some of the things are directed to one direction and some of the things are directed to another direction. We feel like there are two groups of things. So yeah, so you can see these things shows how our mind group things. So using that we in charts we want to show some things related to same group. We want to show that, we want to represent that some things are related to same group. So you can use those principles. The other thing, you can see like in this closure and continuity enclosure, our mind will fill the missing parts and add those things. So you can see like some axis labels and some other grid lines kind of things. You can think like our mind will fill them for us in certain occasions. So you can remove that. Like if the mind filling this continuity, and if the mind draws, even if we remove that thing, you can simply remove that. Like you do not want to like explicitly draw that thing, so you can reduce clutter when you know this Gestalt principle. You can group things. And the other thing is when this Gestalt principle, because they are grouping, if one thing is in a different proximity or similarity, like different from others, and these some different aspect is there for one thing, you can focus into this one. Like you see like this in the enclosed part is more focused. So using this continuity and this enclosure, all those Gestalt principles, we can make some things look more focused. That's also important to make graph. If you want to focus some data, focus some views, you should use Gestalt principles. Okay. Yeah. Now we have discussed about the psychological aspect of it, like this social science aspect of it. Now we will move to some biology, neuroscience stuff. How our mind and brain and this nervous system works when we interact with charts. Okay. Colin Ware is worked on ocean mapping, and he is best person about this color theory and like behavioral psychology related to color. You can see this is his book. In this book, you can see that like there are three parts. That's the first thing we see. There are three things. So then you can see like there's a on the top part, middle part, and bottom part. Bottom part is more prominent, and in the top part you can see this four is showing in a different way. And here in the middle part is interesting. What's there? We'll enlarge it and see. When you see this, try to read this. Try to understand this. If you try to read the letters, you will not notice all those other images. If you try to trace to a line, you will not see, or you cannot read any letters while doing it, or you cannot see any images. There are several layers. When you try to look at one thing, other things will be, you can see other things, but they are not clear. You can see that. This you can do the practical test right now. Try to read one thing, or try to look at some elements. Some elements are getting less clear. Yeah, this is an interesting phenomena. The problem is, how will this happen? How this is happening? Yeah. We'll go to another interesting example. Count ones. How many ones are there? Try to put the number in chat. How many ones are there? Let's see how much time will be spent. Okay. There's, yeah. There are 1, 2, 3, 4. Okay. What do you think about that? Count twos. How many twos are there? How many twos are there? Yeah. What is the easiest thing to notice? How many ones or how many twos? What's the easiest thing? Yeah, twos is easy. But why? Why twos are easy to find? Because they are highlighted. But the problem really is, why highlighted things are easy to find? Why highlighted things are easy to find? That's the interesting question. Why something is easier to find when it is highlighted? Okay. We learn about the eye in our schools. We know that there is a lens, and there is like retina. There is a lens, and we when we look at something, the outside image will focus to the lens, and that will create an image on the retina, and we see that. So yeah. So when you learn that, yeah, when you learn that, some students think that we, as it is, from, it's like a camera, we just get the picture on the retina, and we just process this image, and at instance we know what's in the outside world. But that is not how vision works. Vision works in a very different way. You can see here, even though even though we are getting an image in the retina, so you can see this is something like pixels. The resolution of the eye, like eye and brain work together, so the resolution of the eye, you can see in the middle part there's a very high resolution. So it's very crystal clear, like we can identify the things in the middle crystal clear. But when you go to the sides, the resolution is not very good. These are blotted. So when you look at something, you will get the image into the eye, but the problem is only the very middle part of it will be get processed, not the complete image. So so when you look at something, you only going to see that thing. You will see all the world, you will see all the front area of your view scope, but that is blotted. You only see the middle part, the very middle part, the very thing you are looking at clearly. So if you are only seeing something small part of the things in the front area, now the problem is how we see the world. As we are seeing, we see some continuous world. we see in some continuous world. So how we see that? The thing is, there is something of saccadic eye movements. When we look at something, our eyes move here and there very fast. Our eyes moves and here and there very fast, and they trace the images. It will go to more important places. It will go here and there, and then after that it will map it will get a lot of images, and they will get high resolution in the middle part, and brain processes that all. Brain processes all those images into what we are seeing. It's not like a single thing. It's not a single step thing. We are looking, when we look at a particular object, when we are looking at a room, our eye will very quickly go here and there, very quick. It's very sudden. We do not think about that motion. It's a very quick motion. We do not feel it. Our eyes will be quickly go through here and there and grab information, grab photos, grab images, and brain processes them all, and we feel that something we are seeing at the room. So if this is the process, now there are two things, like we only see the very thing we are looking at, the middle section, the middle point of the very thing we are looking at, not the outside. So on the sides we are only seeing very like blotted picture. So there are two things. Eye has the saccadic eye movement, so eye plans how the eye plans this motion, saccadic eye movements. Eye plans where to look at next. It is some involuntary procedure, like we do not feel it, but eye plans it. So if we can manipulate this planning, if we can manipulate this planning mechanism, we can grab focus of the viewers. We can grab focus of the viewers, and we can keep audience. We can keep the viewers' eyes where we want. So so it is very important to know this area as well. And these are like a lot of behavior studies around that, very interesting things. You can read them in Colin Ware's book. A lot of behavioral studies are there. So you may have noticed something like when you're looking at a stage drama or like movie, you might notice that you know who are in the left and right to you, who are sitting left and right to you, but you know there are some people, but you do not know who they are, because in the like surround this like near to the circumference, it is a very blotted view. Only in the center there is the only in the center we see the more like informative view, like high resolution view. When we looking at a stage drama or movie, we are looking at it, we are focused on that stage drama or movie, so we only see those people in the left and right from our circumference area of the slides eyes. So we have a blotted picture about them. We know they are sitting next to us, but we do not know who they are. I think it's a common experience. Now, now we will go into some color vision related ideas. You know, this is electromagnetic spectrum. This is like red, lower frequency, and here violet, higher frequency. You see like red, green, and here like violet and blue color comes. Now, yeah, there's another thing that some people get wrong. Some like yeah, they how many primary colors are there in the like how many primary colors are there? How many primary colors are light of the light, and what are they? Primary colors of light. Many people will say red, green, and blue. Red, green, and blue. But there's a problem here. one thing, first question, can we create all the colors mixing red, green, and blue light? Can we create all the colors we see using red, green, and blue light, mixing all three colors? No, no. There are some colors that we cannot generate it by RGB. If we try to try to like give RGB values of those colors, some value might be negative, like R or G or B or like anything like some value can be negative. There are some colors like that. There are some colors we see, if we try to get RGB value, it will have negative components. So mixing lights, we cannot get all the lights. And the other thing is, it's not only red, green, and blue. There are a lot of color triplets that can generate a significant amount of colors. But red, green, and blue is something they like, they just chose. Like here's the red part, here's the green part, here's the blue part. And so is about the eye also. In eye, there are cells, we see colors. There are different cells, and some cells are more sensitive to this lower frequency range. We call them red cones, and in the middle section there are green cones, and there are blue cones. On there are three types of cones that capturing different parts of this color spectrum. Now you can see something here. This is a retinal imagery. You can see there are in some parts red, there are a lot of red. There are some parts there are a lot of green. Here red is more prominent, but in some images green is more prominent in some parts of the eye. But blue is rare. You can see blue is very rare. The blue cones are very rare. So we have a very weak sense of blue. So that's why we feel blue as a dark color. Dark means less light. Dark means less light. Black is no light, like less light. So why we feel like blue is more close to black and blue is very darker? Because this blue there are lesser blue cones. There are lesser blue cones in the eye, so we feel blue as darker. So why we feel yellow as very brighter, very lighter? Because yellow means red and green. Yellow comes with like red and green. So when we see some yellow thing, when we see yellow, all the red cones gets like simulated, and all the green cones get simulated. So we saw yellow things through a lot of cones. So we have a very powerful sensation. That's why we feel that yellow as bright and blue as dark. That's the neuroscience about it. And here the first question I asked, why highlighted blues are very easy to identify? Because when our brain sees things, things go into this is a theory. And when we look at something, first these responses go into behind of the brain. Behind of the brain there is a V1 part. V1 part do basic processing, basic colors, basic shapes, basic intensities, so on, basic textures, so on. And after that, this is called visual cortex of the brain. So after V1, they will go into more complex shapes, like these 2, 1, 3. These digits are made of like combining elementary shapes. So these numbers are processed in the V2 part. So when you see something, first the signal will go into the V1 part. Only after some time, it will go into the V2 part. So it is very easy to identify colors, textures, and other stuff because they are elementary and they are processed in the V1 part. And comparative to them, it's hard to identify numbers and figures kind of thing, because they are processed in the V2 part after that. So you when you make these saccadic eye movements, like there are two ways. Like there are voluntary things, like we think and where to look, and then we look at there, and there is something like we just involuntarily we look at that place. So it happened like this, like the things we think voluntarily will start from the front brain, and the signal we go into the back of the brain, behind of the brain, and the involuntary stuff starts from the back of the brain and go into the front of the brain. So the things we do involuntarily, like them without knowing if we are looking at things, it is those sensations are governed by this back of the brain. So if we can manipulate how these the things that the back of the brain is sensitive, we can involuntarily grab attention, involuntarily grab this focus of the people. Yeah, and there is, after that it will go like the object detection and this spatial where are the things are, like where kind of sensation, that space sensing, all those things like start from back of the brain and go into front. And yeah, you now know like why like this highlighted things looks more why we are focused at those things. Now when we talk about this color vision, you see there are red, green and blue sensations. Now they are going to V1 area of the brain, and in the V1 area of the brain they are processed into 3 channels. This is an old theory, but it works, but the recent theories are more complex than that. So there are 3 channels. There's a luminosity channel, bright and dark. That is the very prominent sensation. Dark and lighter, bright, dark and brighter. Those things are that is the most prominent sensation. There is a red green channel. Red is one thing, green is opposite. Yellow and blue channel. Yellow and blue are opposites. Red and green are opposites. Like black and white, dark and lighter, brighter. Those things are opposite. The most powerful sensation is this dark and lighter, and then yellow and blue. Red and green is a bit not that much powerful, but those are the 3 like this is the 3 color channels that we ultimately brain process. We can manipulate those things to show contrast. You can see these 2 dots are same color, but you might see like one dot is more brighter and one dot is darker, because this is happening because ultimately the brain process in colors to a color channels. When they process color channels, they show the way they show the difference, this luminosity difference, like this light and dark difference in compared to the surroundings, and this blue and yellow difference and red and green difference. So you can see this is same color dots, but you will find it different because the brain process it in like opposite difference. Like brain captures it as a difference with the surrounding. So here blue and yellow, this is same color, but you might feel it different. This is red and green. So this is same red color dot, but comparing to the surrounding, you will feel it in a different way. Okay. This is about this open process theory, and you can manipulate those information to create good contrast, good visualization with a contrast. And main thing, red green, you think like this is more prominent. This is more prominent. Like dark and light is more prominent. Yellow and blue is like a little bit less prominent, and red and green is even lesser. It's some weaker. So when you make like contrastive, when you want to mark contrasting graphs, you should first start from this. This is the most powerful sensation. This dark and light is very important. Try to use that as well, that very much. And yeah, and some practical stuff again, small thing. This RGB color scheme, but the problem, there is a problem here. RGB is not for humans, it's for machines. It is how machines identify colors. Mixing colors, it is how like machine generate colors, but how humans identify colors. There's another color theory. From that it will come this HSV color scheme. Some people might know that HSV is the more like human color perception. There is something called hue. Hue means the color, like in your small like in your childhood use, when you said color, you meant hues. Like you can see different hues. That is what people usually say, colors, hues. And then you can say this value. Value is the lightness and darkness. You can see like we can be light. This is black and gray and white. Likewise, light blue, dark blue, so on. Like this is value difference. There is something called saturation. This is a very subtle difference. Saturation means you can see here, this is more gray. The same value, but this is more gray, this is more color. If there's no color, then it is gray. Black, white, gray means there's no color. Like there's no red, green channel, or there's no blue, yellow channel. There's no color. Saturation means how much color is there. Like it is like gray, and how much red we are going to add to this. So using hue, value, when we choose a color as a human, we first look at hue and we choose a color, then we choose at like value, light blue or dark blue, and then there's a subtle thing, this saturation, like grayish. Do you want to make it more grayish or not? And yeah, I discussed that most prominent sensation is the bright and dark. That's the most prominent sensation. So you can see in the black and white movie era, like this is Metropolis. You can see how powerful that image is. It's very powerful, and it looks very serious. And then color film movies came, and color movies came. This is Wizard of Oz, and I don't know if you know like film movie related history. Like this is a very landmark thing. Like there's a place named Kansas. In this Kansas place, there's only like black and white. Like there's no color. And in Oz there is color, and they show like how these things change from like colorless world to colorful world. But the problem here is both of these are like created by trained directors. So both of these can be said good, but you can see even the black and white is really good. You can see like some early black and white movies in Sri Lanka are really good with the pictures, but now when color comes, they are lesser good pictures in movies and TV shows. Why is that? Because color is very difficult thing to handle. So the most powerful sensation is the luminosity, like brightness and darkness. So if we are going to add more saturated color, if we are going to add more color, so then we lost this luminosity sensation. So we should not overuse color. That's the key thing. The gray, black, white, these are very good. And color is also like good. It can give us feelings. It can provide us sensations. But color should be color is something rarely used. We should rarely use color. Otherwise, if you're going to fill it with different colors, everything will be get into a mess. It's getting into ugly. That's why in recent films, like the people going into like more desaturated color frames, like more grayish. The problem is that the going into grayish is okay, and almost all the designs, look at those phones and cars and other mechanical designs and other things also. Now it like in 80s, people try to use more color, more and more color. They overuse color. Now they are also like less colors. So then they can give like more professional look, serious look, and more like brightness, darkness sensation. Yeah, in movie industry, there's a problem now. They are reduce the luminosity contrast as well. I do not know why they are doing that, but that's why world is more like reduced color use, because color is something difficult to handle properly, and we should rarely use it. Otherwise, everything will be get like childish and messed up. Okay. Then we are going into the last sections of this one. Now we learned about the clutter. We learned about the clutter. We remove the clutter. Now the next thing is we have to focus our key messages. So to focus our key messages, when you can see when everything stands out, nothing stands out. We should not stand out everything. We should not try to focus on everything. We should first understand what is the key message we want to focus our viewers, and we have to focus that thing. We should remove clutter, and then we should then focus into the thing we want to say. You can see this chart is like everything is focused. Now here, business and medical faculties are recently started. Now it is focused into this thing. Now it's clear to understand. It's no problem. You can create different charts. You can create more charts. You do not have to put everything together into a one chart. You should identify what you are going to focus in the particular chart, and you should focus that thing and remove all the other things, and you should de-emphasize all the other things. And it's okay to have like lot of several charts, because then the message will be clear. Do not try to put everything in a one chart. You see here, this table is there. We can focus things. You can see here like this 1C school, type 1C schools is focused here, and here like here Uva province is focused here. You can see the difference. Like when you present something, you use those things. And there's another thing. You should increase accessibility. I'm not going to ask what is the number you see in this, because some people will see 74, some people will see 21, and one of those groups are colorblind. Some colorblind people see another like different number. This is a standard colorblind test. So when you create a chart, you should have to think about colorblind people, blind people. Blind people cannot see charts, but there are ways to address them also in chart visualization industry. Those are like advanced topics. But colorblind people, so you should there are some tools like color contrast checker, this like colorblind simulator. You should use those tools and check like if it is accessible to colorblind people. And you should think about the education, like education levels, like if you're going to like give a chart for a large audience, you should ensure that the people can understand those charts. Like even the less educated people should understand the chart. The other thing is, you have seen that in some books you are getting photocopy, and photocopy is black and white. When you got the black and white picture, everything like chart, you cannot read the chart. If you have created a good chart, it will not happen. Like even if you get the black and white chart, there's enough luminosity contrast there to like enough dark bright contrast there to get that into the photocopied paper also. These are the important factors. Like there are a lot of things, a lot of research stuff and a lot of practical stuff. I'm like going in like very surface level things. So so you can go into depth. The other thing, data storytelling. Data storytelling means when we present data, I have seen like this is in lot of presentations, lot of conference papers like that. I have seen this like I have seen people show like they selected this village and get a sample of 200 people. They get this school get a sample of 50 people, and they show just the statistic. Just they like to eat these things. They come into school from these vehicles. So they just show data. The problem is no one is interested on that 50 people. No one is interested on that that particular 200 people of the village. When you do research or when you're going to show something, when you get a sample, you are trying to grab something more broader thing. You are going to identify some broad phenomena using that sample. So you have to do a storytelling. You have to tell a story using that sample. You have to tell a story. What is the important thing you have identified from that sample that we can apply it in a broader context? So data storytelling is important. So rather than just showing graphs, you have to focus. Focus is the key for storytelling. You have to focus. Here you can see like the latter part is focused, and when two employees quit, then there's a gap between receipt and process. So business owner should immediately hire 2 employees. That's the key message. That's the key story. The story should be visualized. The easy way to do that, when you going to present some data in a like research paper or conference or presentation or report, just ask yourself the question, so what? So what? You just show data, so what? Why it is important? Why you are showing this data? And try to identify that. What's your story? What do you want to say to the audience? What do you want to express? And focus that. Okay. Yeah, I'm going to like this mixed method. Mixed method means quantitative and qualitative research. Sometimes there were ways like quantitative research is there, qualitative research is there. There is something called mixed method research. In the mixed method, we use both qualitative and quantitative data to get explain some phenomena, to study some phenomena. But there's a problem in the way people present this mixed method research. You can see, like I read this from Evergreen's blog. She said, just read it. Like when she was in university, like the people, like the way they present their presentation, the front contain the quantitative result, and back there is the qualitative result. And you know, like the same thing is true for even for normal papers as well, because we in the result section we are writing quantitative findings, and in even in quantitative research we write quantitative findings, and in the when we have this conclusion and this conclusion section, and then this there's another section before the conclusion. I forgot that. Yeah, in the last sections, like we show these qualitative things. What are the qualitative information we can get from this quantitative data? Even in mixed method, that's more prominent. But the problem is they put quantitative data into front and qualitative data into backward. So the reader has to map them to map the front to back. There's no relation. There's no there's no link. It is hard to like when they show this, when they look at these qualitative findings, they have forgotten these quantitative results. So it is very hard, you see. Then Evergreen said, like why is that happen? Like why this bad thing is doing to the audience? Because usually, like, it's because of the laziness. Like universities have quant teams and like qualitative team and quantitative team, and in large research, like there are a lot of teams, and there are quantitative team, qualitative team, and quantitative team wrote their part, qualitative team wrote their part, and then they put that together, and then they publish it or present it. But that's a very bad practice. We should have a coordination team, and like we should coordinate between the qualitative teams and quantitative teams and get the final broader view about the data, and we should focus like quantitative data in the background of these qualitative findings. Okay, chart related miscommunication, the other part. You can see I just said in the beginning, like this chart is really bad. Why? In the y-axis, you can see this starting from 35 to 75. So that means this is bar chart. Bar chart is drawn to compare lengths. Bar is a length, and we compare these values with lengths. So if it is starting from 35, how we can compare lengths? Because our lengths are length is something like this 53.35 length should be something starting from 0. If the bar chart is not starting from 0, this bar length, we are seeing a wrong length. So our comparisons are wrong. So this chart is really bad chart. So why? It has not started from 0. When you use a bar chart, you should start it from 0. Okay, in this one you can see like live discharges and deaths, and here they get how many male to female percentage is discharged lively out of a hospital, and how many male to female percentage get die in the hospital. But the problem is there's not much meaning in that way. Because like when you get that percentages, there's no much meaning. If you want to get the meaning, you have to think about like males and females separately, and this out of males, how many live discharges, how many deaths? Female, how many live discharges, how many deaths? These comparison is the one we want. Out of live discharges, how many male, female? Out of deaths, how many male, female? We know like that is a very small count compared to live discharges. Therefore, when we put like bars like that, we give some wrong impression. Like we feel something deaths are like something comparable with some live discharges. Like live discharges are very high, deaths are very low. Otherwise, no one will go into hospital if deaths are that high. So you can see this is a bad chart. This is meaningless metric. This percentage is meaningless. You can see this chart here, January, February, March, April, and these values are there. If you present it as this, you can see it looks like large change. There's a huge change, huge increase, exponential increase. If you graph it like this, it will look like there's not strong change. There's a like moderate change. It depends on the axis. Like what I have done, I have just changed the x-axis scale, like x-axis scale and y-axis scale, the lengths. Here the x-axis is more narrower, and here it's more broader. Then we feel completely two different things. So when you create a chart, just know like you have to know about data. Otherwise, you do not know what is the correct size to convey correct message. So if you want to communicate correctly, you have to you should know about data. Otherwise, like this can be a significant increase, this can be a like moderate increase. That depends on the context. Without knowing context, we cannot generate real like good graphs. We should know context to create good graphs. Okay, small data set visualization. For small data set visualization, do not use pie charts and do not use percentages for small data set. Small sample, small data sets. This is the like very last content. Never use percentages and like summarizations. Very careful if you have to use. When you are using a small data set, like I know like in Sri Lankan universities, usually like there's no much funding to do large research. So mainly you are working on small data sets. So when you show small data sets, do not try to give like counts, percentages, especially percentages. Do not never use like when I see a percentage in a research, I feel like they have completely got it wrong. Why? Look at this graph. This is like we are giving a math test for a bunch of students, and how many people passed. Like female, you can see like less pass proportion, pass percentage, and males there's a huge pass percentage. Now if you show this graph in a conference or presentation or report, we feel like this is an established fact, like males are clearly better at math. Male students are clearly better at math than female students. But if the data set is very large, if this is calculated using like millions of students, then this if those percentages are there, then we can think like those percentages show something accurate. But here this is the actual data set. You can see like when I now I have represented each point as one a circle, or each female student as one circle, each male student as one square. So now when you mark this past students in blue, you can see like this is not something clear. Like here we say like boys are far better at math, but when we see this, we know like it's not that clear, because the data set is very small, and you can see like there are more female students in the class. So and male students are very like a small number, and the data set is small. Therefore, like just looking at this data set, we cannot say like the boys are more better at math. So so that's something you have to be very careful when you deal with small data sets. Do not try to avoid percentages, try to avoid like counts and aggregated results, and try to avoid these charts that are showing this aggregated result, like these bar charts, pie charts, so on, rather than try to go into like individual level and try to like show each and every unit, try to visualize each and every unit, and those visualizations will give you like realistic sense about the data. More like that's the key thing. There are some I can recommend some kind of charts. There are unit charts, and there are Wilkinson dot plots. There are very nice ways to do that, and you can study like further on these topics. And yeah, this is the end of my presentation. And yeah, okay. I think you enjoyed the presentation, and we will go for a QA now. You can ask any if you have any question or any further clarification or any other tools or these visualizations related other stuff. This how social science and humanities can be used into like technology research, and what are the opportunities you have, kind of all those things you can ask. Yeah. What are the tools you use to make this presentation? I use Google Slide. I hate using PowerPoint because it is not open source. I'm strongly against using track software. So because there are free tools out there. When free tools out there, we should use those free tools without using without stealing them. Then I use Google Slides, and to create those charts, I use Tableau. I can show you like this. Tableau is a very expensive software. You know, I use Tableau Public. It is free. You can see. Okay, you see my screen, no? Complete screen.
Yeah.
Yeah. Okay. Do you see this this screen? Tableau Public.
Yeah.
Yes, we can see.
Yeah, okay. Okay, there's something about like Tableau Public. Like Tableau is a very expensive software, but it gives a like free public version. You can use it. Like Tableau is like, you know, like top people were there, and yeah, the thing is like whatever the tool you are using, the defaults are not good. some like Excel, like the Excel and other stuff, like they're very really bad defaults are there in some tools, but just using default you cannot get a good chart. You have to know and you have to use visualization theory. But Tableau is very flexible, like you can use do a lot of things, so it's a good tool. I can recommend this Tableau. You can see like this University of Mercury take like I can then add this thing, and here I can import data. This is free as long as you are okay to publish data publicly. You have like this here. I'm going to create that. I put year here field here, and I'm going to like engineering intake here, and I'm going to put it to a line chart. So and we can edit axis. We can remove zeros so it's clear in a light chart itself. Then I can remove this header and put those into marks if it is better. Like likewise, there are a lot of things are there. Like Tableau is a good tool. If you can get a paid one, even it's better than this Tableau public. The thing is, after you create this kind of graphic, you can download it. There's no problem with that. You can download it. But if you want to save this, data, and if you want to make this keep this saved, this chart and data, you have to publish. Give it a name, and publish publicly test. It's published. You can see under my profile. Under my profile, it is visible. You can see, everyone can see, like here viewers also come, like it's an active platform. Like some people use like Asia Development Bank, and I have seen like some people use it to publish their open data. So like government institutions and other like research groups can use Tableau Public to create their visuals and like publish them and share links. So this is a free tool. And I have heard like Power BI also have a free version as well. I'm not sure like the capabilities of it, the free version, but Power BI is like, if you think about the paid version, it is less expensive than this. It is less expensive than Tableau. Okay, it is less expensive than Tableau if you use Power BI. Then there are some other stuff as well, like there is some like you know ggplot2. Have you guys anyone know ggplot2? It's in our library. It is like after this Wilkinson's grammar of graphics came, this R library used grammar of graphics. So this grammar of graphics after this concept, that Hadley now R Studio is named POSIT. Now it's a new company, and it's a POSIT, and Hadley Wickham is the chief person there. And Hadley Wickham at that time in early 2000s, he created ggplot2, used his grammar of graphics plot. It is a simplified version of this grammar of graphics, and it can create all the charts like you need in anything. If you're good at coding, ggplot is a good option. And even there are better options like to create charts if you know a bit of coding, like like this G2, this like then high charts, Viz charts, Google charts, like a lot of JavaScript visualization libraries. G2 is specially oriented on grammar of graphics. You can therefore, rather than limiting into the chart types they are providing, you can create your own chart type using grammar of graphics by yourself. G2 is a good one. And there is something called Vega. Vega is also grammar of graphics library, and charting interaction is also like there's something called interaction graphic, and you can use this charting in interaction as well. Then there are something called D-tree. I said about it, like D-tree.js is a visualization library. It's a very advanced tool. From that, it's like binding data to graphics. It's a very advanced tool. If you're going to research into this, like creating these charts, like using D-tree, you can like create amazing, like very different, like innovative kind of charts, like using combining small stuff. D-tree is a good one if you're going into research into this area and you're going to use hiring. And you have used like Elijah Meeks in like he is the one created like some visualizations for Netflix also. Like he's a very prominent guy. There's a Data Visualization Society and he's a pioneer member. And Elijah Meeks is created like there's a book. As I remember, he has a book on like D3JS. And if you know D3, you can go up to higher level. Even Excel is even better. Like if you know how to use, if you know how to change defaults, you can even use Excel. I think like this, there are some videos about how to do that from this Stephanie Evergreen, Colin Affleck. Those people sometimes write like they have paid courses. They are very expensive, but for Sri Lankans. But there are some free videos also like how to do those stuff. Therefore, like yeah, tool doesn't matter. I just use simple tools, and even you can create good charts with Excel if you know how to use it properly. That's the thing. The most important thing is how to use it properly. And I think this some of the charts I saw from those experts, they have created it in Excel. Deliberately show like Excel can, even from Excel we can, if you know this theory, you can create good charts. Why are you using Ubuntu? It's free, and that's what software engineers use, because software engineers, data engineers use, because we can access the kernel and all the system related information. It is easy to, like, it is free, and when you know coding, and if you are working in software or data science or some technical industry, you should use Ubuntu, because a lot of things like are free and you can use them in Ubuntu. A lot of other third-party packages and other things also, and all those like major systems are running in Unix. And if you want to work on these major platforms like this Amazon and other things, it's better to work with Linux. That's like almost like majority of the software engineers, data engineers use Ubuntu. Yeah, is there any question?